In this video, I want to show you how to calculate some probabilities that are associated with the normal distribution using your calculator. I think you'd probably find it a lot easier to follow if you actually have your text in front of you at the time that you're looking at this video. I'll be taking some problems from pages 394 and 395, so that would be where you'd want to turn. A couple of words of advice. You might be persuaded when you look at section 7.2 that the best way to do these problems is to use the standard normal table. After all, that's what the vast majority of the section is all about, is using the table. But in fact, you can do these problems much more quickly and accurately using the calculator. And so that's the direction we'd like you to go in. Two, it's very hard to do these if you don't know the syntax of the built-in functions that we'll be using. And you can find that syntax on page 396 in the text. The functions are listed there in the technology step by step. I also think it's a very good idea when you're getting started working with the normal distribution to draw a picture whenever you're being asked to calculate a normal probability and to label it appropriately. So the type of picture I'm talking about is what you see on page 395 when you look at problem 13 and 14. If you can draw that picture and label it, then you probably have a much clearer understanding of what it is that you're actually doing. And I think that would be a good thing for you to do here. Draw the picture, see if you can match. Anyway, for starters, I want to do number 6 on page 394. And the problem says as follows. Determine the area under the standard normal curve that lies to the left of, and several values are given. Let's do part B. It says z equals negative 1.99. Now the function that we're going to use is taken from the distributions menu. And you can see that at the top of the menu here, there are 3 functions that are associated with the normal distribution. The first one, the normal PDF, which is the probability density function or probability distribution function, we don't really use. We use number 2 and number 3. Number 2 is the normal CDF, that's the cumulative density function or the cumulative distribution function, however you choose to describe it. And number 3 is the inverse norm. For this problem here, number 6, we want to use number 2, which is the normal CDF. So you can access that by pressing 2 or motoring down there and then selecting it. Anyway, this function needs, at very minimum, a lower limit and an upper limit. And in this case, it needs a lower limit of negative infinity. Now the way you do that on the calculator is you key in negative 1 times 10 to the 99. There are actually many values you could use as a proxy for negative infinity, but this is the easiest one to remember, and so I just try to be consistent and do all the problems the same way. That way you don't have to think too much. So anyway, that's negative infinity, and then the upper limit would be the negative 1.99 that's mentioned by the problem. And so that's what we need there. Just close that with a closer. Press enter, and there's the probability right there. If you do another example from this, let's take part A. Oh, by the way, it's customary when you're writing down probabilities associated with a normal distribution or with the binomial or whatever to report these to 4 places. Now, in some cases we might make an exception, like for example the next part here. Let's do part A. This says determine the area under the standard normal curve that lies to the left of z equals negative 3.49. That's 6a, in case you're looking in the text there. So we can just recycle our key sequence for that and just go in and edit that. So we'll change that negative 1.99 to a negative 3.49, and then we're good to go. And you can see the probability there. Now it's given in scientific notation format, and that's kind of unwieldy. We'd much prefer it in decimal form. And if you obviously want to achieve any kind of precision, you might need a few more than 4 places. So this would be one where you might consider writing it to 6 places or something like that. Anyway, let's do another example here. I'm looking at number 8 now. It says determine the area under the standard normal curve that lies to the right of, and several values are given. So let's do part A. It says z equals negative 3.49. I need to key in my argument there. A little hasty with the enter button. So again, this is to the right of z equals negative 3.49, and so that would be our lower limit. And our upper limit would be positive infinity. And so the proxy that we typically use for that would be 1 times 10 to the 99. And we keyed in like that. And press enter, and there's your probability. For number 10, it says determine the area under the standard normal curve that lies between, and then two values are given. So let's do part C. It says z equals negative 3.03 and z is 1.98. Now if you want to understand what kind of advantage using the calculator gives you, I would invite you to consider doing this by hand, and you can see how time consuming it is. On the calculator it's very easy. In fact, we can even recycle our key sequence here and just edit it. So we're supposed to find the area between z equals negative 3.03 and z equals 1.98. So 3.03 comma 1.98, and we can just press enter, and there's the probability right there. Question number 12 says determine the total area under the standard normal curve. Part C says to the left of z equals negative 0.88 and to the right, or to the right of z equals 1.23. Now that type of a region is what you see pictured in the illustration on page 395. Look at 13b. Basically we're being asked to find the area of the left tail and the right tail. And the calculator's built-in function, normal CDF, won't do that directly, so you have to use the complement in order to compute that. So you take 1 minus normal CDF, and the complement of the two tails would be the area between those two values. So that's what we'll take. And so our left limit in this case would be minus 0.88, and the right limit would be 1.23. And so the area that we're looking for is that. And again, if you'd like to see the advantage that the calculator gives you, I invite you to try that problem by hand and see how time consuming it is to do. Anyway, in the next video we're going to show you some additional examples.